In this video, we will practice integration, and we will assume that the only tools or techniques we do have is the U-substitution and integration by parts. Okay, let's see. Exercise number 1. We have some given information. Integral of f of x dx from 0 to 6 equals to 15. And then we have some information about a function and its derivative at the point x equals to 0, 6, 12, and 24. We might need them. Now we have to evaluate the integral between 0 and 12, f prime of 2 of x times e to the power of f of 2x dx. And of course, I did stress out the product times. Okay, let's investigate for a couple of seconds. Definitely we have product. Yeah. We may think about the U-substitution, or we may think about the integration by parts, because integration by parts, of course, is strongly connected to the product of two functions. But what we see a product of two functions, and definitely one of them is the compound function. I can even say two of them, because we have f prime. Okay, this is derivative, but let's hold. We have 2x is the inner function, and actually the second term e to the power of f of 2x. F of 2x, that's definitely the inner function. Either way, before we approach the integration by parts, we have to try U-substitution. Because as soon as we see the compound function and the inner function, we might have to check if that substitution, which I will write down, u, we will let u to be f of 2x, if this will fit to the entire integrand. And then maybe just the U-substitution will be sufficient enough. Okay, derivative of u, of course, is du. Derivative of f of 2x is f prime of 2x times 2, derivative of the inner function, dx. I can divide both sides by 2, 1/2 du equals to f prime 2x dx. Okay, and looks promising since we see f prime of 2x dx in the integrand. This will be replaced, this will be cancelled. I can rewrite this e to the power of f of 2x times f prime of 2x dx. Okay, and then we can nicely see that this part is called 1/2 du. And this will be, of course, e to the power of u. Okay, let's rewrite everything. E to the power of u, and f prime 2x dx is 1/2 du. Let me put 1/2 in front. The constant can be always pulled outside. Okay, and the integral of e to the u du is just e to the u. We do have one more step. Since we use the U-substitution, we change the variable, we have to find a new limits of integration. Let's find new bounds, new limits of integration, okay? Because the original variable was x, x0 and x12. Now we will calculate the new limits, new u. The corresponding u for x equals to 0, we will get through the substitution. That was the substitution. U equals to f of 2x, 2 times x, 2 times 0. Okay, f of 0. It means this limit, the lower limit, will be f of 0. And then the upper limit was 12, but we will have f of 2 times x. X is 12. 2 times 12 is 24. F of 24. Okay. F of 0, f of 24. Perfect. We have a new limits of integration. And now we can apply the fundamental theorem of calculus. We will substitute the upper limit minus, we will substitute the lower limit. And let's get the value from the table. E to the power of value of the function f, just the function, at 24. F at 24 is 7. Okay, and f at 0, that's 0, and that's the value. It's 1. Okay, we may factor out, or we don't have to. E to the power of 1, of course, is 1. This is the final answer. E to the power of 7 minus E times 1/2. Exercise number 2. On a little bit, yeah, let's investigate. Again, we have some info. Oh, actually, for this one, we didn't use that information. It's fine. We might, yeah, depends on the function, on the integrand. We didn't use this, but it's okay. Maybe next time. Okay, we have some given information, the same idea, some given information in the table, and we will evaluate the integral. Okay, let's see what is given. Integral of f of x over x dx is equal to e. The limits are from e squared to e cubed, and some data in the table. We have to calculate the integral natural log of x times. Again, I'm stressing out the product because sometimes we don't know where is the product. Ln of x times f prime of x dx. And the limits of integrations are the same, e squared, e cubed. Okay, let's think for a second, of course. Maybe integration by parts, maybe U-substitution. But what we see, we don't really, even if we will try the U-substitution, we will have ln, let's say U is ln of x, then we will have 1 over x. But then what we can do with that part, f prime, will be not cancel out. Okay. We may definitely try, and if we will see that we're not going anywhere, we can erase everything and come back. But I will give a try. I will approach this integral with integration by parts. Integration by parts. Let's set up our parts. We will need to define u and dv. These two expressions will come from the integrand. And of course, we know that we always, when we see the ln of x, it has to be u. Because it's so easy to differentiate, not so easy to anti-differentiate. And then I can put f prime dx, f prime of x dx as a dv. Now let's calculate the derivative. Derivative of natural log of x is 1 over x dx. And antiderivative for the f prime, it's of course f prime of x, f of x. Okay, we do have everything. Let's see where we're going. I hope it's a right direction. Yeah, let's make the table correctly. Perfect. I will take a blue pen and indicate the formula. Integration by parts is this. We have to multiply u times v and v du, the integration. Okay, let me put this, u times v minus integral v du. We know that, my students know that, okay? A natural log of x, f of x, minus integral of f of x over x dx. And since we didn't change any variable, the limits of integrations stays the same. And this, of course, has to be evaluated from e squared to e cubed. Okay. And I don't know if we can still try to approach this integral, but let's pay attention. This value is given. This is e. Actually, really nice. This integral is given. Okay, let's just evaluate this first part and we will be done. Integration by parts worked. Let's substitute the upper limit. Natural log of e cubed times the value of the function at e cubed minus natural log of e squared, yes, the lower limit, times the value of the function at e squared, and minus e. Okay, I'm still trying. Natural log of e cubed, we know that we can put that 3, the exponent, in front of this. And the value of the function, not the derivative, the value of the function at e cubed is actually 5. Okay, minus, we can put 2 in front of the logarithm. Value of the function at e squared is 3. And e. Okay, let's see. We also know that natural log of e is 1. Natural log of e is 1. 3 times 5, let's just put, okay, 15. 2 times 3, it's 6 minus e. I wish to have the room for the final answer, but we can put 9 minus e. This is the final answer. Let me do this. 9 minus e. And of course, we are leaving this explicit form. Don't worry, we don't have calculators. Okay. And I have one more. 1, 2, 3. Free exercise. I hope you're enjoying practicing with Kasia. Okay, the same thing. Integral is given and the values in the table. Let's don't really read them. Let's focus on the integral. Integral from 0 to 7 x squared times f double prime x, f, the second derivative of x dx. I mean, because we see the second derivative and the product, I will try integration by parts, because we know that we can reduce through that anti-differentiation, that second derivative. Okay, u, du, dv, and v. And we know that algebraic functions are perfect to be placed for u, and since we will be anti-differentiating, this is the perfect distribution of u and dv. Okay, derivative of 2x. Oh, I just said derivative of x squared is 2x dx. Antiderivative for f double prime is f single prime. Second derivative, antiderivative, of course, is the first derivative. No question with this. And our formula, uv v du. uv integral of v du. And let's see what we have. We will have x squared times f prime of x minus integral of 2x f prime of x dx. Okay, and the limits stays the same. We didn't use the U-substitution, we didn't change the variable. Okay, and what we see 2x times f prime of x. We may apply the integration by parts the second time, because we will anti-differentiate this. We will have f of x, and we will differentiate 2x, which will be just 2. Okay, I'm seeing the simplification, but we never know what we will end up with. U, du, dv, and v. A beautiful setup for integration by parts. Okay, algebraic function 2x, and dv will be f prime of x dx. Derivative of 2x is 2 dx. Antiderivative of f prime is f of x. Of course, that's our variable. We didn't change anything. Okay. We have to copy this. Okay, from 0 to 7. Now, that negative will affect our new formula, uv v du. uv v du. uv v du. Okay, and we have this nice arrows. Okay, I will copy. We remember the beautiful presentation of the solutions. Okay, let me, u times v is 2x f of x minus the integral of 2f of x dx. Limits of integrations are from 0 to 7, and we will also apply from 0 to 7 that part. Let me rewrite with applying that negative. Okay, but we can see now we will not know what is this integral because we don't know what's the formula of the function unless we do approximation using the Riemann sum, because we do have lots of data. I mean, not many, between 0 and 7, we only have 0 and 7, but yeah, but we know that value. Okay, we know this value, this integral is 5, so we will use it. Okay, let's see. X squared f prime of x and minus 2x times f of x Everything must be evaluated from 0 to 7, and negative will become positive, that integral. Oh, 2 times that integral. I almost missed that too, because it will be 2 times 5. This is 5. Okay, do I have enough room? I can go to the next page, but let's see. We have to apply 7 first. So we will have 7 squared f prime at 7 prime minus 2 times 7, 14 times f at 7. And then when we apply 0, we have 0 times the value minus 2 times 0 will be 0. Then we can ignore it. Plus 2 times 5. Okay. Let's see. I really would like to. This is, of course, 49, but f prime at 7, f prime at 7, when x is 7, is 1. Oh, luckily nice number. Not so high. And f at 7 is 3. Okay, and plus 10. I think I have to do the arithmetic in my head. 49, maybe I can write here. 49 minus 14 times 3, 42. I have to subtract. This will be 7. 7 plus 10, 17. 17. I hope I did my arithmetic at the end. 49 minus 42. It is 7, because always the arithmetic at the end is more challenge. And 7 plus 10, 17. Okay, that's, of course, must be gone. Okay, I hope you enjoy one more time practicing with Kasia. Please try to redo these integrals again. Thank you.